Now in this video I will show you how to synthesize phenol in different ways. Now process 1. First we take benzene, then we apply concentrated HNO3, concentrated H2SO4. This is mixed acid. I have discussed this process in the video benzene diazonium chloride. Now this will generate nitrobenzene. This will produce nitronium ion and it will undergo electrophilic aromatic substitution on benzene and we will have nitrobenzene. Then you have to boil it with tin and concentrated HCl. This is a strong reducing agent and you will have aniline. The nitro group will be reduced to amine group. Now apply here NaNO2 HCl and you have to make the solution very cold by putting the vessel in an ice cold solution, and this NaNO2 and HCl will give HNO2 which will react with this amine group to give you benzene diazonium chloride. Now when it is distilled with steam or boiled with water, it will give you phenol. So this is one procedure. Here nitrogen will come out, dinitrogen. Now process 2. Start with benzene, add here propene. Now you need concentrated H3PO4, 250 degrees centigrade and high pressure. Now this acid will offer proton to this propene. Now this proton may add here or here. If it adds to the terminal position, then it will be CH3 and you have plus here. And if the proton add to the middle position, you will have CH2 here and the carbocation at the terminal position. Now which one is more stable? This has a single plus I effect, this has 2 plus I effect, this has 6 hyperconjugation, it has 2 hyperconjugation. So stability 2 degree carbocation much greater than 1 degree carbocation. So we have this one as the electrophile, and this will carry out electrophilic aromatic substitution in the benzene ring and we will have cumene. See, this carbon atom has the plus charge and at this position it is carrying out the electrophilic aromatic substitution. So the benzene ring is connected to this position. This is called 2-phenyl propane or cumene. Now air is passed through this solution at temperature 95 to 135 degrees centigrade. You have to maintain the temperature of the solution between this range, in this range, and you have to pass air. Then we will have these two methyl groups are already present and we will have cumene hydroperoxide. Cumene hydroperoxide. Now when this is heated with 10% H2SO4, that is dilute H2SO4. There is a hydrolytic rearrangement within this compound, and we will have phenol and acetone. This one and this OH group give you phenol, and CH3, CO, CH3, that give you acetone. So it is the preparation of synthesis of both phenol and acetone. Since these two products have a huge difference in polarity, this can be separated easily, and this process is called cumene phenol process. In this process we can synthesize phenol. Now process 3. We start with benzene again, and we give here fuming H2SO4, which is called oleum, that is H2S2O7. Fuming H2SO4 means there is H2SO4 obviously, and what is the fume? Fume is of SO3. So add, you get H2 S plus S, S2, 4 plus 3, O7. Now you have to maintain the temperature 80 degrees centigrade, then there will be conversion of benzene to benzene sulfonic acid. After treating it with NaOH, you will have SO3 Na. How this happens? Now this is what H2SO4 looks like, sulfuric acid. Now when it is benzene sulfonic acid, the structure becomes this. So you have another OH group left, and this is the replaceable hydrogen atom. So this compound is acidic, and when it reacts with NaOH, there is a formation of a salt and water. So it is benzene sulfonic acid, and it is its sodium salt. It is the sodium benzene sulfonate. Now solid NaOH is taken in excess, and it is fused at 350 degrees centigrade. We have the byproduct Na2SO3, Na2SO3 and we get phenol, but since the environment is basic, we get its salt form. So we have sodium phenoxide or sodium phenate. Now when this is treated with dilute acid, say dilute HCl, we have phenol. Now process 4. In process 4, we start with benzene and apply here bromine and Fe dust. Remember, if we apply bromine and HNu or heat, there will be no reaction, since aromatic ring does not allow free radical substitution. Since an aromatic ring is electron rich, it allows very easily electrophilic aromatic substitution. Now this Fe reacts with bromine to give you FeBr3, and FeBr3 is a Lewis acid. It extracts Br minus from here, so you have Br plus left. That will carry out the electrophilic aromatic substitution here, and you will get bromobenzene. Now metallic magnesium is added in presence of dry ether as the solvent. So we have the Grignard reagent. The name of this Grignard reagent is phenyl magnesium bromide. We have a minus here and a plus here. Now we made it into two halves. Half of this phenyl magnesium bromide is kept aside, and we proceed with the remaining half. We pass here O2, which gives us this peroxo compound. Now this half which was kept aside is added. So we can write here half and here half phenyl magnesium bromide. Now here we have two oxygen atoms and here no oxygen atom. When these are mixed together, there is a distribution, uniform distribution results, and we have one oxygen atom in each. So half plus half equals to 1. Now when this treated with dilute HCl or any other dilute acid, we have phenol as the product. Now lastly, the famous process, the Dawes process. The mechanism of the Dawes process is very much interesting, and I will present it in a separate video. So the last procedure I am showing you is the Dawes process. Now first, to carry out the Dawes process, you have to convert benzene to chlorobenzene. So here also you give Cl2 and Fe dust, that will generate Cl plus, which will undergo electrophilic aromatic substitution on the benzene ring to give you chlorobenzene. Then you have to apply 6 to 8% NaOH solution, and you have to heat it at the temperature 350 degrees centigrade at 300 atm pressure. So at this point there will be nucleophilic substitution. Since an aromatic ring is electron rich, it does not allow nucleophilic substitution. So to have this possible, you need a high temperature and pressure. I will discuss it in detail in another video. So you will have the Cl substituted by OH. Now, since the environment is alkaline, you will get sodium phenoxide. So again, you work up with dilute HCl or H3O plus, then you will have phenol. So we have discussed 5 processes of synthesis of phenol.